Continuing on in our unit on exponents, what we're going to cover today is a concept called rational exponents. To get a better understanding of rational exponents, let's just talk about a couple of things, a couple of them which are familiar to you. You learned earlier two laws in our 7 laws of exponents. The first one is if I am multiplying and the base is the same, I would add the exponents. And if I have what's called power to a power, I multiply those exponents. Now, let's take a look at that with the following situation. If I have the square root of 4 times the square root of 4, hopefully you realize that that equals 4. Okay? Because square root of 4 is 2. 2 times 2 is 4. Now, using our rule up here, 4 to the half power times 4 to the half power is 4, because 1/2 plus 1/2 is 1. Okay? The square root of 4 squared, hopefully you realize that that is also 4. Okay? And then 4 to the half power squared is also 4. Now, why did we go through all of that? Well, hopefully you'll see that all of these are obviously equal to 4, but they're all in a different format. And so what do we notice here? Well, 4 to the half power times 4 to the half is the same thing and gave me the same answer as radical 4 times radical 4. So what can we conclude? And 4 to the half power squared gave me the same answer as the square root of 4 squared. So what conclusion can we draw? That all are equal to 4. So 4 to the 1/2 power is equal to the square root of 4. That gives us our first definition that we're going to deal with in terms of rational exponents. And again, all rational exponents mean is that it's a number raised to a rational power. And remember, the term of a rational number is a number that can be represented as a ratio of integers. And so 1/2 is an example of that. So our definition is if n is a positive integer greater than 1, and the square root or the nth root of a is a real number, then a to the 1 over n power is equal to the nth root of a. Okay, so let's now go through some examples of this, which should hopefully be pretty clear. 81 to the 1/2 power, hopefully you realize that is 9. Negative 27 to the 1/3 power. Now, this concept of negative numbers raised to a power is always a little tricky for students. So what I'm going to do is rewrite this, so hopefully this will be a little bit clearer. So what I want to do is imagine that this is really negative 1 times 27 to the 1/3 power. Okay? Well, what's 27 to the 1/3 power? That is 3. It's the cube root of 27. So the answer here is negative 3. Okay? Negative 9 to the 1/2 power means the square root of negative 9, because the negative sign is contained inside the parentheses. Well, what's the square root of negative 9? Well, no real number. You got to wait till algebra 2 to get to that. Remember, why is that the case? Because no number times itself that's a real number gives me a negative. 16 to the negative 1/2 power. Well, let's remember our rules with negative exponents. I would rewrite it as 1 over 16 to the half, which is 1 over the square root of 16, which is 1/4. And then lastly, 5x to the 1/4 power. Hopefully you're seeing that it's only the x that's being raised to that 1/4 power. So 5 times the 4th root of x. Please make sure you write the root as a smaller number. Okay, now, what happens if the numerator of our fraction is a number greater than 1? Well, let's think about this for a moment. 8 to the 2/3 power. I can rewrite that as 8 squared times 8 to the 1/3, right? Because the rules tell me that I I can break this up into two parts. And I'm sorry, not 8 squared to the 1/3, but 8 to the 1/3 squared, like that. I'm sorry. Okay. So, because my power to a power rule tells me that I would multiply those exponents. Well, 1/3 times 2 is 2/3. Well, we know that 8 to the 1/3 is 2, and then we would square that afterwards to get 4. So, what is the definition when I have a number other than 1? If m and n are positive integers greater than 1, and the nth root of a to the m power is a real number. And let me just move this up a little. Then a to the m over n is equal to the nth root of a to the m power. Okay? Also, you might see it sometimes written as the nth root of a to the m power. Okay? They're interchangeable. All right, so let's do some examples. 16 to the 3/4 power is the 4th root of 16 cubed. A little easier to do it like this because I'm going to make the number smaller first and then make it larger. The 4th root of 16 is 2. 2 to the 3rd power is 8. Okay? And I'm going to show you how to check these in class on the calculator. Okay, negative 27 to the 4/3 power is the cube root of negative 27, and then I'm going to take that to the 4th power. Well, if the the root is an odd number, it's okay to have a negative in there because that's really negative 3 to the 4th, and that's positive 81. Okay, 8 to the negative 2/3 means 1 over 8 to the 2/3, which is 1 over the cube root of 8 squared, which is 1 over 2 squared, which is 1/4. Just to scroll this. Negative 9 to the 3/2 is negative 1 times 9 to the 3/2, which is negative 1 times the square root. You don't need to write the root of 2. You can. So that's negative 1 times 3 cubed. So that's negative 27. And then 4/9 to the 3/2 power. Remembering our rule, we would distribute this exponent to both. Okay? The square root of 4 is 2. 2 cubed is 8. The square root of 9 is 3. 3 cubed is 27. Now, how would I write the 5th root of x cubed in exponential form? X to the 3/5 power. How do I write 12a to the 4/5 in radical form? 12, 12 is not necessary to be put in radical form. The fifth root of a to the fourth. Okay? Now, last two examples. I have 27 to the 5/6 times 27 to the negative 1/6. Well, what would you do with these exponents? Add them. Now, hopefully you realize that 4/6 can be simplified to 2/3. So this is the cube root of 27 squared, which is 9. And then lastly, 8 1/3 plus 8 to the 1/3 power plus 27 to the 1/3 power squared. Well, you should remember that our special rule of distributing the exponent doesn't apply because of the addition. So I have to evaluate the cube root of each. I get 2 plus 3 squared, which is 5 squared, which is 25. So to just quickly summarize, rational exponents mean exponents that are rational numbers. The numerator of the exponent tells us to raise that to a power, and the denominator is the root of that number.